be talking today about self-replicating serverless function or functions. As you know, serverless is going to take over the world. And I thought, what's a better way to help it other than have functions which generate some more functions, and those functions generate even more functions, and everything will replicate. Maybe it will expedite the process. Self-replicating code is not new. It's called a quine. A quine is a non-empty computer program which takes no input and produces a copy of its own source code as its only output. We'll play a little game on that, because we will actually replicate and still print output, but that's the usual definition. What does it mean? It means, for example, that this very nice shell script, which prints itself, is not a quine, because it actually takes the output from the file system, right? So this program, yep, it's empty, is unfortunately not a quine too. It does reproduce itself. And actually submitted as a code to one of obfuscated code contests as a program which reproduced itself and won. But it's not a quine anymore. People refined the rules after that. This is a very nifty, concise Python quine. We'll take a little different approach. People usually strive to make the quines as small as possible. It's considered the intellectual exercise to do that. But don't ponder too much, because we'll take a simpler approach. We'll start with not a computer program, but with simple English language. And you'll see that say twice, if you'll actually follow the instruction, is a good quine, because you say twice. So that's easy to go. And we'll evolve this pattern, this text, into fully working code. So first thing code does, it doesn't say things yet, or almost yet. It writes it. So write twice is a very good, again, English quine. And to be able to discuss the pattern, we'll call the first part the command, because that's what it does. It tells us what to do. And the second repeating pattern, the stanza. You'll notice that write twice is not very well defined. Some people might say the word twice when they're told to say twice or write twice. We'll write the word twice itself, so we want to somehow mark what the stanza is. So we'll quote it. This, unfortunately, is no longer a quine, because nothing in this text generates the quote marks. So we can improve on that and say, look at this text. Write once without quotes and once with quotes. Write once without quotes and once with quotes. That's another example of a good English quine. You'll see an important concept that we can see in this example is the fact that we actually use escaping. You'll notice that quotes appear both as a symbol and as text, as a word in the English language, which is a concept we'll carry on throughout the talk. Instead of just referring to the stanza without calling it by name, we'll advance even further. We'll try to get more and more precise in our text until we get to a fully working JavaScript and Python code. So if we do write the stanza without quotes, write the stanza with quotes, and then put the stanza, we get, yet again, a working quine. You'll notice that we never defined the stanza. So we'll go and do that. Just amend the part that says write the thing and the stanza is. This is, however, no longer a quine, because the text didn't regenerate the stanza is part. Also, it is very customary to define something before we initially use it. Not mandatory in all languages, but makes things clearer. Fixing the first part is very easy. We can just write the stanza is just replacing the order, basically. And I also added a new line, both for clarity and because it's actually, when produced, is the new line after the quote, the quotes there. So it's precise. And to amend this text, In order to print the stanza, we use a literal and say the stanza is, write the stanza is, write the stanza with quotes, write the stanza without quotes, and again, we're happy and content because they have a fully working quine in the English language. Now, this pattern is so strong that we can morph it into working JavaScript code very easily. And we can see that. I hope it's big enough that everyone can see. The same pattern holds. We start by defining our stanza. So const stanza equal backtick. In English, you use usually quotes. In JavaScript, we use backtick for multi-line strings. You can see that the stanza is simply the definition of the backtick, our escape character, basically. And we build the quine itself in memory as a variable. We can const stanza equal, the backtick, the stanza itself, the backtick, the semicolon, because it's clearer this way, and the stanza again. A proper code would have, there are some new line issues in this example. The GitHub repository holds a completely functioning code that actually works and deployable to your accounts. But that's it. So, and the stanza repeats again, that's actually the code that we execute. So let's see what happens when we run this code. We define a variable called stanza, we define the backtick, and we build the quine. What is the quine? Const stanza equal the backtick, the stanza, the backtick, the semicolon, and the stanza again. It's working perfectly well. For those of you who prefer Python, the same pattern is still working great. We define stanza to be a multi-line string, and instead of the backtick or the quotes, we use the marker, which is 3 quotation marks, and generate the same thing again. So we're happy. Obviously, nothing we do never goes untested. So if we'll run the quine.js code and diff the outcome with the source itself, we get no diff, which makes us happy. So that was general quine pattern, but nothing serverless yet. We want to take that and evolve our code to go serverless, because we want to have a function which generates itself. Amending the code to do that is, again, relatively easy, because we take the steps one at a time. We introduce into our stanza, and for brevity, I didn't copy the entire stanza again. You by now should understand that the same pattern is simply appearing twice, just as in the say twice example. So we define the handler of the Lambda function. It's a AWS function, but obviously there's nothing specific to it. And instead of console out, console log the content, we use the callback to return the response. Since my deployment uses the Lambda proxy, I want to pack it in a format that probably most of you know, which is the response with the status code and the body as the quine itself. And again, very similarly, in a similar fashion, we do the Python code, maybe a bit simpler because we don't have to resort to callbacks, but same pattern. And again, we verify it. So I didn't opt it for the live demo because it seemed the demo gods were not with us this conference. So everything is public on GitHub. The link will be on the last slide, so you can check it yourself. But that's not over. What we want to do is introduce, that was the first part. We actually made a serverless quine. We want to extend it to deploy itself, which is another nice thing we can do from a Lambda. So it's a Lambda that deploys another Lambda. To do that easily, we want to add a hook to our pattern. And here again, for brevity, I remove the stanza parts altogether. We have a hook that can do whatever we want with the inputs with the event and with the quine itself, so it will have everything included. And still, because we want it to be a standard quine, return itself no matter if it succeeded or failed or anything like that. And the hook will simply be any function that we want that will call the callback. So what do we want to do there? We want to deploy. Unfortunately or fortunately, depends on your perspective, to deploy code, you need to have a zip file containing the files that you want to deploy. And we have to have the content, the zip, in our quine. So there are three approaches. One can embed the binary representation of that zip in the code, and it will have to carry it over. But that will be very unreadable, since zips can have an uncompressed contents. One can even assemble it in runtime, but it's not very readable code. One can simply add a library that zips the code into the quine, but then it becomes a very large quine, and again, very unreadable. I opted for the third option, which is making a simple service, a serverless function, basically, that zips whatever files are sent to it, and then returns the zipped content. So a very simple accompanying, and we take that as part of the environment or operating system if you want to help us assist. I could have used the zip file, but zip unfortunately is not in the container that runs the Lambda function for some reason. So that's a very simple zipper file using the adm-zip node package. It iterates over all the keys, all the file that it got, add them, and produces an output, the content of the buffer zip. The semi-magical numbers there are simply permissions for Amazon to read the file. So that's the octal part. Now armed with the zipper function, we want to implement the hook that let us redeploy ourselves in another function. So what does the hook do? In order to deploy functions, I forgot to mention, other than the code itself, other than the zip, we need to supply it with a role. And roles usually contain account IDs and might contain other privilege information. So we take it from the environment, and we feed it back to the environment, hence completing the loop of the replicating ourselves. So the first thing we do is know which role we are and which role to deploy the function from. Then if we are asked to do a redeploy to a specific function name, we check for it and keep the function name as is. We invoke the zipper helper service function to zip our content. The index.js is the common choice for a Lambda file. We then simply call the Lambda API create function. It's not on this screen, but Lambda is actually the object that is generated from the SDK, which is available again in our system, so it's legal to use it. And basically that's it. We now have a fully working self-replicating JavaScript function. Again, nothing goes untested, so if we just call the replicator, it returns itself. If we call it with function names equal replicated, it still returns itself. But then we can invoke the result and verify that it generates the same thing. You'll see that I'm no longer using curl to touch the function because we never generated the API gateway rules to do that. That would have made, again, the quine very, very complex. So we have to resort to using the CLI. And that's basically it. There is a, yeah, that's an Ouroboros. It's a nice, I have 15 more seconds. So there is another evolution of quines is to make a quine which generates another part. So in this example, it's a JavaScript program that generates a Python program which regenerates the first JavaScript Python. It's called an Ouroboros, like the snake that eats itself. And you can see that the same pattern holds. We have a JavaScript stanza, a Python stanza, and the alteration here is that there are two stanzas, and the one containing the actual language is repeating again. So, and the Python code looks exactly the same, right? It says the same stanzas, only with different markers for escaping. And that's it. All the code that you've seen is on Binary's GitHub account, and you can reach me at Twitter, Michael Adda. Thank you very much.